And then I've got a handout. Okay. So last time, in fact, I'll go before last time. Because last time, what did we do? Who remembers what it was we did last time? Implicit differentiation. Differentiation is another word that sounds like a drum. Try to say it really fast. Just like the judicial system. The judicial system. Guys, everybody. So before that, we did chain rule, and then we did implicit, and then we did inverse tricks. We've got to finish out the inverse trick stuff. Okay, very excited. Inverse trick, yes. So let's do this. Let's kind of talk about chain rule for a minute. That wasn't on today's quiz. It will be on the quiz we're having on Wednesday, though.
Which Wednesday?
This Wednesday. So I'll talk to Jen. She'll be okay. So quiz Wednesday on 3.4 and 3.5. So 3.4 was chain rule, and if I'm not mistaken, 3.5 was implicit. Yes. And you are very welcome. You want more grades, my God. I'm going to make this one a little bit shorter and to the point. I'm going to have like 2 chain rule problems and then 1 implicit. Okay, yes. Yes, because what's happening a week from this Wednesday? Test. Yeah, it's crazy. So Wednesday's the last day to give it to you and give it back to you before the test. Yes. Okay. So chain rule is just if I have a function inside of another function that's more than just x. And I think I told you this. We do chain rule for everything. So just to get you guys on board with that idea, what is the derivative of sine x? And what's the inside function? 1. No, what is the inside function? X. So when I multiply by the derivative of it, now the derivative of it is 1. So we eternally do chain rule. We are always doing chain rule. But the only damn time chain rule really gives me anything useful is if the inside is more than just x. The inside always gets a turn. So it's sort of like if I have a gear running, but then I have another gear inside going crazy, the total motion of the dude should be dependent on both its own motion and the motion of the outer gear. Does that make sense? If I'm on a train and I'm walking like this, I'm going much faster than this relative to somebody standing next to me because the train's going too. So both motions have to interact. When an inside is just x, the inside is changing by 1. It's not really contributing anything. So help me out. What if I had sine of 2x? This happens very, very, very often. How do I take its derivative? Yeah, the outside function is sine. It's sine of stuff. And by the way, there's a million different ways to write this.
The inside is just 2.
The derivative of the inside, yes, but hold on. You could write all this weird shit, and you can if you want to. You could say outside is sine x, and the inside is 2x, and you do all this weird shit. And if it helps, great. I don't see a reason for it. So what's the derivative of sine of stuff? Cosine of stuff. Then the stuff gets a turn. And what's the derivative of the stuff in this case? So I put that out front so it doesn't get lost. Poor little dude. Yes. So since the inside gear was rotating at like a double speed, it ended up doubling the whole speed of the whole thing. You can kind of look at it like that, yes.
If you were to do the prime of that, 2 cosine 2x, would you do?
All right.
Yeah.
G double prime. Would you do what?
Would you like also do the 2x that's on the side again?
Let's try it. So how do you take the derivative of cosine of stuff? Cosine. Negative sine of stuff. Was there stuff inside?
Yep.
It gets a turn. What's the derivative of 2x? 2 times 2? 4. So who can guess what G triple prime would be? You're gonna pick up another factor of,
Negative 8 cosine.
yeah, you're gonna pick up another factor too, so it'll be negative 8 cosine. The next derivative would be positive 16 sine. You guys start to see the idea. Every time I take a derivative of something that has 2x inside, the answer's gonna double. Why? Because the derivative inside is gonna have another factor of 2 come out. Maybe. We're good? Alright. Okay. Get you young people's vernacular. Groovy. Oh, I love it. You actually thought it was a big thing. No, you guys say it's groovy? Alright, let me see.
Going back?
So, what about if I have something a little more complex? So, let's see. So, at this point, we know the natural log of, let's take one step back, of cotangent of 4x squared. Now, when you first look at this, you know what rule is going to come into play, correct? I mean, very obviously, because what am I focusing on right now? Freaking chain. But I'm going to give this to you without being in the context of chain rule. What tells you this is a chain rule?
The fact that there's a function inside.
I have a function inside of another function. It doesn't matter how many I've got inside of other ones. No, it just matters that I have a function inside. I know it's going to be chain rule. What's the outside function? That's the only thing I care about at first. So this is natural log of stuff, correct? Everybody remember how the natural log's derivative works?
1 over x.
Yeah, natural log of stuff, the derivative is 1 over stuff. But then who gets a term?
The cotangent.
Yes, the inside shit gets a term. Let me see if I can really get you guys to be on board with me. You know, like, good luck, man. Prime, there we go. I did the inside function, I did the outside function, and I keep pointing at it, it's not gonna work, Jeff. This function's derivative is 1 over stuff. Then the stuff gets its own term. Every rule we've learned so far, every piece gets its own term. Oh, I'm sorry. We don't need that part of the book just staring at us. Dadgummit, go away. Everybody do this. Everybody do that. Okay. Here we go. Look, see? I know it took that also. Everybody with me so far? So you don't have to know ahead of time almost anything. It's a natural law. Okay, I know that. It's 1 over stuff. And then this, now this is its own problem. This business here, this right here, it's just sitting there. It's done. It's just gonna come for the ride. It's already done. It's just waiting for the other guy. So this just comes for the ride. I just have to write it. What do you do? But all my attention can now be focused on this guy. What's gonna be involved in that guy? Freaking chain rule, because it's got stuff inside of it. I love it. I didn't have to know that ahead of time. So what's the derivative of cotangent? Negative cosecant squared of stuff times
Stuff.
not stuff,
Times the derivative.
derivative of stuff. And what's the derivative of 4x squared? How do I know I'm done? Because there's no function inside anymore. The inside function is x. So I know I'm done.
And then you can just bring the 8x
Now I clean it up a little bit.
and put it all over.
What should be in the very front?
8x.
Almost. Yes, negative 8x. And then I have cosecant squared 4x squared over cotangent of 4x squared. Now you could argue that you could simplify these trig functions further. I don't care, it's fine, this is plenty, right? Because this is cosecant 1 over sine squared. And cotangent's cosine over sine. Do you see how a sine can cancel? Who cares? You're fine. This is beautiful, yes? If you want to do the trig, a little tear for you. Alright, I need you to be with me on this. Do basic simplification for damn sure. I will take points off if you don't do basic simplification. What do I mean by that? If you have 2 and then you have a 4, it's almost like you better freaking make that an 8. You better put it out front, right? I mean, just basic simplification. Okay, you guys, is that all right so far? Okay. So here, you guys try this one. Mix. Okay. Poor Jeff. What have I done? You have the answer or you have a question? Don't say the answer. I want everybody to think about it. Yeah, sure, eventually, yeah. Chain rule, definitely. Big time. Big time. By the way, real quick, before I forget about it, everybody was asking me if this was like where that -2 was. If I wanted it to be inside, I'd have to do this, right? In fact, the funny thing is everybody that asked me the question drew these and said, do you mean this? And I'm like, if I meant that, I'd have to put the parentheses there. That is a completely different problem than sine 4x and then take 2 away from that. Those are 2 completely different problems. All right, I just want to say that before I forget. Okay. So what's the very first step? Well, the very first step of this kicks so much ass. Because what's the outside function?
E.
Freaking e
Is
is
stuff.
stuff. And what's the derivative of e is stuff?
E stuff.
E is stuff. Times
Stuff derivative.
derivative stuff. Now, I need you to understand, if you write the rule, you have less to keep in your head. Some of you guys try to write with that and keep it in your head. Don't do that. Just write it for yourself so you can see what the hell you're doing. Write the rule. Now I can do the derivative. Now I can see it staring at me. That's its own little problem. If I gave you this problem, it's much better than this problem. Does everybody agree? Because that's a part of this problem, and it says more shit. So it's obviously, it's automatically better. So that's its own little problem. What does it involve? Product rule primarily. Some of you guys might know this has got chain. I don't have to know that at first. Right now it's 4x times sine x squared. It's the product of 2 functions. So how do I do that?
Derivative of the first guy
Good?
times the second guy. What's the derivative of the first guy times the derivative of the second guy?
Oh my god. Okay, hold on. Eraser's the most important thing. Oh, you're back to normal. How did I do that? I wish I knew. Sorry, what's up?
Your S is the main.
Oh, my S. Okay. And then I'm missing this guy. This guy. I believe that's what I meant. No, that's not what I meant. This guy. Okay. I'll get it. Okay. Look at this. Technology makes everything so much better. Is that alright? No, that's great. Okay. So 4x prime sine x squared plus 4x sine x squared prime, right? That's the product rule. How does everybody feel about the product rule right now? You gotta love the shit out of that thing, right? It's only the parts that can give you trouble. The rule itself is very straightforward. So this is still sitting there waiting, like all of you. This one I'll do. Oh boy, okay, I'm done. That took me a while. Now, how do I do the part that I need for this? Now I can focus on this. So 4x is just sitting there. How do I do the derivative of sine x squared?
Cosine x squared. Oh, split it up into the sine x squared and the x squared.
Be more specific. What rule am I using on this? What's inside the sign? Alright, so what rule am I using? Chain rule, yeah. So what's the derivative of cosine of stuff? Cosine stuff. And then the stuff gets a stern, so I'll just put 2x. Is that cool? That's the derivative of the inside? Yes. That's yes.
Would the parentheses be with the multiplication sign?
With the what?
Would the parentheses be?
No, not really. No, because this is attached to this. Isn't that the term it came from? Where that 2x come from? It's there because of this piece. It's attached to this term, yes?
But so what would be?
It's not attached to this term at all. It has nothing to do with that guy. Where did this 2x come from? It came from this guy. So it's attached to it, yes. Okay. Good question though, I mean, I get that all the time. So I mean, isn't this its own function right here? Isn't that its own function? Isn't it adding to other parts of this other bigger freaking function? But it's its own little function. So if I do its derivative, all its parts should be right there. Because it's its own little function piece. Now what can I do? What can I put together? Yeah, I can put these together. Can I put them over here with this 4?
No.
Of course not. It's a plus sign in the middle. I can't jump over that thing. You know, like sure you could, man, if you lay it on the ground, jump. So I can't bring this over there because the plus sign, of course, right? That's pretty much as you should try to do. Okay, maybe. It's all about step by step. That's what it's all about. If you try to get to the answer quick, you'll get to the answer quick. It'll just be the wrong answer. That's so funny, Jeff. I know, but it's true. That's so cool. Okay. So the last stuff we did. So that's cheap. The last stuff we did was implicit, which is basically chain rule where it doesn't tell you everything, right? So the whole idea of implicit is, I'm not going to do this again, but if I have x squared plus 2 to the 7th power, what's its derivative?
X squared plus 2 to the 6th power.
Yeah, 7 comes down, x squared plus 2 to the 6th power, times
The derivative inside.
derivative of x squared plus 2, right? Go with me. You make me think like, we'll come back to you. Now go with me.
You can move that around too. Like,
Oh, the little ball dude? I know. But there's no great place for him to be, so. Alright, you should be fine. Right, yeah, okay. Alright, right there. Is that cool? Oh, I need to put that back. Times x squared plus 2 prime. Okay. If it was natural log of x to the 7th power, how would you do its derivative?
Seven
Yeah, 7 in
times
front of stuff
the stuff
to the 6th
to the
power
6
times
That's the derivative of
1
that.
over x.
derivative of the ln, which will be 1 over x. I know. So on each one of these I'm not done, correct? But that's not my point. I don't care. I'm making a point. So what if I just didn't tell you? Yeah, I didn't tell you. The function is in there. Alright, Jeff. What's its derivative? It would be 7 in front of function to the 6th power times the derivative of the inside, right? So let me go even one step further. Let me just call it freaking y like we used to back in the old days. So I want to take its derivative. 7 in front of the function to the 6th power times the derivative. And that's all implicit is. That's all implicit differentiation is. You're assuming y is a function of x because it's inside of a relationship with x. So whenever you take a derivative of something with y in it, you better multiply by y prime because that's the chain. Yes, that's what implicit differentiation is. Every single one of these, didn't I change the inside function? Did that really matter for the first step? Every first step was exactly the same. So that's all this is saying. So, with that said, I understand. Holy shit, implicit gets detailed and so much crap to keep track of. I totally understand that. So like, alright, let's make one that's not too crazy. Are you capable of that? I don't know, let's find out. Minus xy equals 3, sure. Oh, I do want to show you one thing. I'll do it here in a minute. Well, all the x's cancel, Jeff. That's not very good. 3x squared. Okay. Plus y. Okay, I can't stop. Okay, there we go. That's it.
Sure.
So when I go to take a derivative, what rule is going to apply here?
Oh, product.
Product, 11. So derivative of x times y squared plus x times the derivative of y squared. What's the derivative of y squared? 2y. What's y? Isn't y a function of x? So what's the derivative of something squared? 2 times something times the derivative of something, yes? That's implicit differentiation. Why didn't I do that for this guy? The first guy. I did. What's x prime? Freaking 1, because we're assuming it's dy dx, yes? That's what that says, believe it or not. Okay. Keep it on going. What do I have to do here? Here's the big mistake people make. Am I not subtracting this whole thing? So I better subtract its derivative, right? Derivative of x is times y plus x. What's the derivative of y? What's the derivative of y? Y prime. Yes?
With the y square at the very beginning,
Yes?
how come that's not y prime as well?
Because I didn't take a derivative of the y piece. What did I do in this very first thing where it says y squared? What did I take a derivative of to get there?
You did
X. I took the derivative of x, and that's 1 times the other function. And what's x prime? 1. So it's gone, effectively, right? This one, I took a derivative of y squared. I took a derivative of a function that has a function in it. Derivative of something squared is twice that thing times the derivative of that thing, yes?
So basically what we're doing in this is we're just finding the derivative of one, so like dx over dy.
We're going to solve for dy dx. We're going to solve for y prime at the end. But we have to know how to develop each piece so that I can get all my y prime stuff together. Yeah.
How come you got 2xy, but you need y squared as gx?
If I have 5x squared, what's that derivative?
Times.
That's right, 2 times 5 times x, yes. Yes. So what's the derivative of xy squared? It would be 2 times x times y. Just like 2 times 5 times x, right? Times the derivative of the inside function, because is the inside function just x? No, it's some function of y, it's y. Yes?
How'd you get the plus x times y prime?
Over here? Okay, so xy, what's the derivative of x times y is this guy. Then I leave x alone, what's the derivative of y? Y prime. Yeah. Yes.
So why is the beginning not x, y squared? Why does it not stay this? Like, why is it just y squared?
Because how do I take the derivative of a product? I take the derivative, this is kind of cool, I'm gonna do this. I take the derivative of the first guy, what's the derivative of x? 1 times the other guy. There's a 1 there if you want, yeah. Okay, okay. I like it. It's very trippy. I'm not trying to tell you this is easy. I'm trying to tell you this is easier than you're assuming it to be. That doesn't make it easy. It's just easier than you think it is. Let me write all this again without all this looking like a football play here. Okay, that's where I am right now. So then we have to do this side. What's the derivative of 3x squared? I'll do it. Man. What's the derivative of y? Okay. Now here's what I was going to do in my 180L for those of you in that class. I had a whole worksheet that was all about solving for a variable when it's all over the damn place. Because what do I want to do right now? Somebody just asked me.
You want to solve for y prime.
Solve for y prime. What first thing I got to do is distribute the negative, yes? And then what do I want to do? True, but to get to that goal, what do I need to do? Everything that has a y prime in it, I gotta get it to one side. Everything that does not have a y prime in it, and that's exactly like algebra. How do you solve an equation? Because you get all your x's on one side, all the non-x stuff on the other side. We normally call them numbers, because at that point it's just numbers. So yeah, I want all my y prime stuff on one side, all my non-y prime stuff on the other side. So you can do this either way you want to. I don't care. Which way do you want to move stuff? Yes.
On that, when you were thinking the second half where you had the x times the derivative of y squared, did we multiply by y prime because we don't know what y is? Y is a function still.
Yeah. If I have something inside of a square, would the 2 come down in front of the stuff, and then the stuff gets a turn? That's all that is. So whatever y is, I have to take its derivative. What could y be? Y could be x squared plus 2. Y could be natural log of x. Right? That's the idea. I'm just putting y in place of this thing. I don't know what it is, but whenever I see it, it's got to act like any other function of x would. Yeah. Is that right? Okay. And now it's just algebra, this part. Oh yeah, I left him out, thank you. I got so confused about my little X dude. Poor little guy. Okay, so now I could, subtract y squared and add y, right? I just gotta pick a side, just like you do in algebra. So I'm gonna pick this side, I'm gonna put on the left-hand side on my y stuff, my y prime stuff, sorry. So I'm gonna subtract y prime, and I'm gonna subtract y squared, add y, subtract y squared, add y. So I can get all my y prime stuff on one side, all my non-y prime stuff on the other side. Okay. So I get 2x, y prime, gone, minus xy prime, minus y prime, equals 6x, gone, minus y squared plus y. Oh my gosh. So now I got everything with the y prime in on one side, everything without on the other side. This should be the easy step. Because now what do I do?
Factor out y prime.
Factor out of y prime. Oh my gosh, so much right. Then I divide by this business. So then y prime equals this. So if I want to find a tangent line at some point, I have to plug the entire point in, the x piece and the y piece. Because the y prime requires x piece and y piece. Yes, sir.
What would the y piece be then? Would you give it to us?
I'd have to give you the whole point, yeah.
Okay.
Yeah, if I don't give you the function, then I have to give you the full point. Oh my gosh. Okay, that's one bad thing about that. Good lord. Alright, so let me shut the hell up for a minute. I'm gonna give you guys a little practice sheet with implicit. Yes?
If we got it backwards, is that fine? Like,
What do you mean
got it the
backwards?
other way? Like, if we move the stuff to the other.
Oh, then all your signs are different, correct?
Yeah.
You're fine.
It's fine.
Yeah. 4 minus x over x plus 1 is the same thing as x minus 4 over negative x minus 1. Yeah. Oh my gosh. I gotta figure something else about that. Alright guys, I want you to try to do the first 3 problems. Yes. Test. Yes.
We're all the.
We already got
Because when we take the derivative of this, so far, really try one more time. You guys get one? No. Alright guys,
Yeah, we got some extras.
well done. Alright, I don't know, I'm not good with numbers. So real quick, just to
That's
give my
kind of bad.
hand a break, let me try this, no, it was meant to. I do that in like the first day class when I pass hand still by out and I don't count the right number, I'm like, I'm not good with numbers. And everybody's like, oh shit, where am I? So guys, real quick, there was remember this problem just a minute ago?
Ugh. Yeah. I don't like it.
I took its derivative and I did derivative of x times y squared plus x times the derivative of y squared. Now, the question is, why is the derivative what it is? Right?
Because we have no idea what the.
Yeah, so let's focus on this guy by itself. So this guy right here. What would this guy's derivative be? Well, what if I gave you
2y.
sine x squared? How would you do this derivative? And I know I just did this. I know I did. But I'm going to do it again. How would I take that guy's derivative?
I take the 2.
2 comes down.
The times the inside derivative.
Through the inside. Okay, what if it was natural log of x squared?
natural, 2 natural log.
2 comes down in front of the function times.
Times 1
Now,
over
I
x.
need you to understand. Do you see how the very first step, I could make any frickin' function I want to, and the very first step, if I put it inside the square, the very first step will be exactly the same, yes?
Mhm.
I can make the inside. Do it, Jeff.
Oh.
Yes? Yes?
Yeah,
When that
but
just-
then you
the
would
two
have
would
to
come
do
down,
the derivative of
the
the
2 would come
inside.
down. Yes, the 2 would come down in front of stuff.
Mm-hmm.
Time, and to the first power, yes, times derivative of stuff. Now, are we gonna like the next step on that problem?
No.
But at this point, is that true?
Yes.
Yes! Do you see how every single one of these, it's the devil inside, no, has the same exact idea, right? Do you understand? I can put whatever function I want to there. So I'm like, I'm tired. I'm not creative anymore. It is all gone. It's been a long ass day. I'm just gonna say whatever function I decide. I don't know, just call it y. I'm tired. How would you take its derivative? The 2 would come down in front of it, and then it gets a frickin' term. That's what every single one of those says, yes? The 2 comes down in front of it, and then it gets a term. That's what every single one of these says exactly that. So whenever you take a derivative of something with a y in it, and we're doing implicit differentiation, you have to multiply it by y prime, because that's the inside function. Just like, why you had to multiply by sine x prime? Why? Because sine x is the inside. That's all, that's it. So, try the first 3 on that handout. Oh man, this got kind of rough. Yeah. Oh. What's the derivative? Okay. Exactly. So really what you do is you take the derivative of y is y prime. Done. Next. Yeah. Or you could do like you just said, derivative of y is 1 times y prime. They both end up with you. Okay.
Did I set this up right? Because I don't want to continue if I didn't get it right. So I did.
Yeah. So it's y plus x prime. Beautiful. That's because y prime equals. No, you just didn't take this guy's derivative. Whatever you did on one side, do the other side. Yeah.
Right.
That's the only mistake. Good.
Well, let's let him explain it, and if it doesn't make sense, then I can see if I can.
So guys, this is x squared times a function of x. They just didn't tell me what this function of x is, right? So how do I take the derivative of x squared times another function? That would be what rule? Product. So what's the derivative of x squared? 2x times the other one.
Y.
Plus, leave the first dude alone. What's the
X
derivative of
squared.
y?
Y prime.
Y prime. Okay, good. So far, so good. I don't know what y is, but whatever it is, I have to take its derivative on that next step. Okay. What's the derivative of cosine of something?
Negative sign.
So the sign changes, yes? Negative sign is plus sign. And what's inside the sign?
A Y.
And that's a function of x, correct?
Mhm.
So I have to multiply by its derivative. This is just changing. So again, it's really easy to forget. But if I had cosine of 3x squared minus 2, say negative, right? What's this guy's derivative?
Negative.
Positive sign.
Good,
Positive
negative sign. So
sign.
sign of stuff
3x squared minus 2
Times
derivative
the
of
derivative
of stuff.
3x.
right? And then you keep going. That's all we just said. I said, okay, instead of this, I'm gonna put y there. So instead of this, I'm gonna put y. That's all we just did. That's it. When I have a function inside that's more than just x, I have to take its derivative. And again, we do it with x is just 1, so it doesn't really show up. Yes?
Didn't I do that earlier when you checked mine?
I'm really sorry, Brendan. I don't know.
Okay, cool.
I can't, I would say no, that you did something adjacent to this, but I don't remember.
Okay.
Incredibly enough, I don't remember. And then on the other side, what do you get?
3.
3. So the other thing that people forget is they'll focus so much on one side,
Yeah.
they forget what they do to one side, you have to do to the other side. So I take the derivative. And now it's just algebra. So this step, if you could survive to this step, the rest has to be easy. What's the only thing on this problem that's in the wrong place? 2xy is the only thing in the wrong place. And then I can take out y prime. Let me see if you guys are cool with this. I'm going to divide by x squared plus sine y is. And then if they gave you a point, you plug it in, figure out what the slope is at that point. Yes.
Wouldn't it be negative sign?
I don't know. For which one? No, why would it be negative sign?
Because,
Derivative cosine is negative sign, negative is plus.
oh, never mind. I was thinking about subtraction.
You guys good over there? What's up?
I kind of did mine not entirely differently, but I did my algebra differently, and I got 2xy minus 3.
Oh yeah. Over negative x squared minus sine y.
Yeah.
You're fine. You got the same thing as me. Do you all agree that 6 divided by negative 7 is the same thing as negative 6 divided by 7?
Yeah.
That's all. That's it. If you take the negative out and put it up top, you get the same thing I did. Yeah. Yes.
Why wouldn't it be y prime squared?
Oh, okay. Help me out. Good Lord. Help me out. AX plus BX, what comes out? A plus B, correct? You cool with this not being x squared? Of course it's not x squared, because they each only had one x. There's not two x's, there's one that was distributed. There's not two y primes, there's one that was distributed. So I skipped a step here, and I'm really sorry. I took a y prime out, and was left with x squared plus sine y, and then divided by x squared plus sine y. Yeah. Just trying to show you a little shortcut there at the end.
So, at the end there, the original problem, it says like equals 3x, but at the end you're just like equals 3.
Of course I did, because what did we do to this side? I took its, what did I do to this side to get here? We took its
Derivative,
derivative. You can't do something to one side and not the other side. So what's the derivative of 3x?
3.
There you go. Okay.
Oh,
So that's a really common mistake is somebody focuses so much, especially when I have a lot on one side and very little on the other, we don't remember, oh yeah, I gotta do the other side, derivative, yeah. Okay. So you're not alone, Mike, you're fine. Now's the time to make the mistake. So how should I rewrite this guy first before I do any derivatives?
well, you wanna move that, why you gotta like that?
All right.
We're gonna do, yeah, just that. We did.
So how do I take this, the derivative of the sine of stuff? Cosine
Cosine
stuff.
stuff times derivative stuff.
How do I take the derivative of something to the negative 1?
You use the power rule.
Yeah. The
So
negative
that
1
would be positive,
comes down and makes it plus,
positive
y
y
to
to
the-
the negative second.
and then the stuff gets a term. Of course it does. Poor little stuff. Again, what's inside? What's inside? Why? It's a function of x. So do I have something inside that's more than just x? Yes. I can't assume y equals x. I have no idea what y equals. Equals, now here's one you can get away with, Mike.
E to the x.
Yeah, so you can forget to take it through and you're fine. It looks like you know your shit, right? Okay. So that's a nice one. That was, you can forget that one and be fine.
Free.
This is free. So then you get cosine xy, it's just sitting there. What's the derivative of xy? Derivative of x is times y plus x times the derivative of y. Now this one is a little tricky. You gotta be a little careful. What do I have to do next?
Minus cosine of xy times y.
Not, you can't do that quite yet because this stuff isn't free. I have to distribute. Someday I'll actually give myself enough room. Okay. And now what's the only thing that's in the wrong place? What's in the wrong place?
Y cosine of
Yeah, this guy's in the wrong place. He doesn't have a y prime. Everybody else over here does. And they're all like, get out of here. You are cheese. Oh my god. Right on the edge. Jiminy Jeebus. That
And that's why you have an iPad.
is an XY. Yeah. Just want to give my hand a break. So let me see. Let me write this a little better. Can't be any worse. Be quiet. There we go. That's better. Okay. So now I can take out. Right now, the minute we're at this step, we're in algebra now. We're done with calculus. It's all algebra. And of course, this is where people go, yeah, so algebra suck. Oh, well. So now I try to distribute so things are free to move around. I get all my y prime stuff alone, and then I can take a y prime out. Now, dear God, are you guys cool with this little mini shortcut? It would be this side divided by everything here that's absent the y prime. I'll take a y prime out, so I'll be left with x cosine xy plus y to the negative 2. You guys see that? If I took a y prime out, that's what it would, the y prime be in front of, yes? Yes? Yeah, of course. You can see how these problems get really long pretty quickly and easily, right? Oh, good. I remembered to turn it on. Okay. So the biggest problem with these is well, I won't say it's the algebra. That's not the biggest problem. The biggest problem is really understanding the idea of implicit differentiation. I do want to show you one specific kind of problem. We'll finish up this worksheet later, but I want to show you one specific kind of problem, then I'll let you guys out. See if I can make this really quickly a little bit. Yeah, let me make one that's not terrible. Okay. So I'm going to be very specific. I want dy dx, but I want to show you. This is so cool.
Oh.
So I'll start doing this, right? This will be 1. And what happens over here?
2y
Y prime, good.
3y
3y squared, y prime, yes. So then, can everybody see this be y prime equals 1 over 2y plus 3y squared?
Not immediately, but eventually.
So if I take a y prime out and divide by that business, yeah. That's all I'm doing. Okay. Here. And then divide by that stuff, okay. Now very quickly, this formula is not that horrible. But watch this. I'm gonna do, instead of that, I'm gonna do dx dy. So dx dy. So now I'm taking the derivative with respect to what? Y. Good. So what's the derivative with respect to y of y squared? 2y. Done. Because it would be times dy over dy, which is freaking 1. So if I take the derivative with respect to y, Now it's the x shit that's got problems.
So this is
Now x is a
implicit.
function of y.
This is implicit.
And then what's this?
3y squared.
3y squared. Now you ready? This is what kicks a lot of ass. This is dx dy, correct?
Uh-huh.
If I want dy dx, I just flip the damn thing. I flip the damn thing. Isn't that what we just got? Isn't that what we just got? Yeah. Okay. So it's kind of cool. It blew my mind the first time I saw this. If it's easier to solve for dx dy and they want dy dx, solve for dx dy and then just flip everything. That's almost too nice to believe. Yes.
So dx over dy is also known as x prime, right?
Yes. And now you see why prime is not good enough. I know we've been using prime a lot, and it's partially my fault because I've been trying to focus so much on the rules. But I gotta start incorporating dy dx notation because that becomes very important because very soon we'll be taking derivatives with respect to time. And we have to be really explicit what the hell we're doing.
So is this still implicit differentiation?
Yes, this is still implicit. The next time we'll do 3.7, we might do 3.9. We'll see how much time we have after the beautiful quiz we're gonna have. It's gonna be a
Okay.
beautiful quiz.
Back to
Most beautiful
this.
quizzes. Okay.
I'm sorry. I'm not. I got. So I figured out that the second